All right, today we're going to talk about the focus and directrix of a parabola. And for our purposes, we're going to leave the vertex at the origin as we get into some of the example problems. But let's just talk generally, what are we talking about when we talk about the focus and directrix of a parabola. So here's a parabola. Here is the vertex. The focus is a point located on the axis of symmetry. So if I draw this imaginary line through the vertex, the focus would be a point here, and the directrix would be a line down here. And what we say is the distance here from the vertex to the focus we call P is the exact same distance from the vertex to the directrix. And the directrix here is a line that is perpendicular to our axis of symmetry. And in fact, by definition, in terms of the parabola, if I pick any point on the parabola, the distance to the focus, and I'll use a little geometry putting a 1 hash mark there, is exactly the same as the distance from that point to the directrix. And that's true of any point on the parabola. One of the applications here is if you think about a headlight or a flashlight or a satellite dish, the focus is a critical point here. One, for a flashlight or headlight, that's where the bulb would be. And so what happens is the angle at which the light hits the parabola, it reflects it off at the exact same angle. And so as that light hits different parts of the parabola, it will all end up focusing in the same direction. And then for a satellite dish, they will put the microphone there, same thing, because as sound would come in, it would reflect off at the same angle and land at the focus. From an equation standpoint, and there's a couple of different forms of the equation. The one that we're going to use for a parabola that would open up, it's y equals 1 over 4p x squared. And you see our p here. We'll talk about how do we find that value. If it was a parabola that opened down, and we know that's negative, so negative 1 over 4p x squared. If we were to have a parabola open to the right or the left, for one opening to the right, we have x equals 1 over 4p y squared, or rather to the right. If it opened to the left in the negative direction, we'd have negative 1 over 4p y squared. Okay, so let's look at a couple of examples. Again, for our purposes now, we're going to keep the vertex at the origin to make things a little simpler. And I'm just going to sketch a graph on my paper. You would actually do this on graph paper to be more accurate. So I'll just put a little y equals 1 over 4p squared here as our model. So we're trying to get it into this form first. So we're going to solve this one for y. So we have 2y equals x squared, y equals 1/2 x squared. Okay. So we know we have a parabola that opens up because it's an x squared and a positive a value, a positive leading coefficient. And we know the vertex is at the origin. So again, I'm just sketching here. We know that's the general shape. So now we know the vertex, we'll put that here. And we're going to try to, we are going to find the coordinate of the focus, which we know would be here, and we're going to find the equation of the directrix. So we take our a value and we set that equal to 1 over 4p. I'm going to cross multiply. 4p equals 2, p equals 2/4, which is 1/2. So that tells me that that p, which is this distance here, is 1/2. So we're just going up 1/2. So the focus is at the coordinate 0, 1/2. And then this would be the directrix, which is the line y equals negative 1/2. All right, our next one, we have a y squared. So we know that one's going to be something that opens either to the left or the right. And we're going to solve this for x. So we're going to multiply both sides by a negative 4. So we get x equals negative 4y squared. Again, we know the vertex here is at the origin. And because of the negative leading coefficient, we know that our parabola will open to the left. So we're going to take 1 over 4p equal to negative 4. Again, cross multiplying, negative 16p equals 1. P equals negative 1/16. So that means this distance from the vertex here to our focus is the P, which is negative 1/16. So that means our focus is at the coordinate negative 1/16, 0. And then here would be our directrix, and it's a vertical line, so that's x equals. And so the directrix would be x equals 1/16. One more example here. Again, we have a y squared, so we know it's going to be a parabola that opens either to the left or to the right. And so I'm going to solve this for x. So we have 1/2 x equals y squared. So we end up with x equals 2y squared. All right, again, our vertex is at the origin. We know because we have a positive leading coefficient, this one's actually going to open to the right. Get a little sloppy there with my graphs. So we're going to take 1 over 4p again, because again, going back up here to our parent, right? That a value is equivalent to 1 over 4p, and our a value here is 2. Cross multiply, 8p equals 1, p equals 1/8. So here would be our focus. Again, that's our P, so that would be at 1/8, 0. And there's our directrix. Again, it's a vertical line, so it's x equals, and so that would be at x equals negative 1/8.